Thanks, everybody, for joining us for this Data Center Summit session, Generative AI, Network Considerations and Impact to Data Center Designs. It's being sponsored by Siemon. It's being delivered by Siemon's Senior Director of Global Data Center Sales, Gary Bernstein. Gary, thanks very much for joining us. A quick message to our attendees today. You have a questions button that has two purposes. Submit questions for Gary. Very interesting topic he's presenting to you today. Any follow-up questions you have for him, go in that question button. That's also where you can get some tech support. If something's not going right for you, question button is where you can reach us for that support. So there's more information about Gary in the speaker tab on your player, but I don't want to take another minute. I want to turn it right over to Gary now to deliver a lot of important information about generative AI, what it means for cabling. Gary, the floor is yours.
Thank you, Patrick. Hey, everybody. Appreciate taking some time today. I've only got 30 minutes, so not too much time to cover a pretty complex subject, but hopefully this will be beneficial to you guys. So I'm going to start out. Here's kind of what I'm going to cover, just a little bit on some of the market forecasts, some of the use cases and technologies that we're seeing with AI networks, the higher bandwidth requirements, and some of the network considerations in DC designs. First, I'm going to kind of go back through a little bit of the background and the timeline. It's been really an amazing ride the last year and a half. It's an exciting time in our industry. And, things kicked off back a little, year and a half ago, I guess, in November with ChatGPT, initially coming out. And I'm going to just kind of highlight some of these things. Google and Microsoft introduced their a chatbot, some leaders in the industry kind of highlighting, that we're at a really a revolutionary point and a tipping point throughout the industry. NVIDIA being the market leader really in this space so far has been very active. And, the end of last year, I think everybody's probably followed the NVIDIA stock. That's been crazy last year, and even this year today, it just split 10-1 on Monday. But again, a lot of the GPUs, I think the number I saw was last year they shipped 2 million GPUs last year. And then just a few months ago, NVIDIA introduced their latest chip, the Blackwell, faster, quicker. So it's moving very quickly in terms of the technologies. So just very quickly, kind of want to highlight, what is Gen AI and what does that look like? So I borrowed some stuff from NVIDIA. They've done a nice job of summarizing a lot of the technologies. And if we really look, there's kind of two different parts to Gen AI, and there's really the training application, training models, and inference. And this is a diagram that really just kind of tries to explain it. So if I look at the training side first, it really is taking data and it's learning new capability from existing data. So in this example, it's looking at pictures and videos and so forth of cats or dogs, and training this model to distinguish that it is a cat, in fact. And they're using deep learning to do that training. So from that, you really end up getting a trained model and some form of a capability with that. Then it moves to inference, is really just applying that application. So like those chat bots are an example of inferencing in that application. So it does see a particular data, an example of a cat, let's say, and it distinguishes what type of a cat that is, and it is a cat. So that's kind of at a high level what that what the two different types are. So let's talk next about use cases and really the applications that we're seeing in the marketplace. And again, this was from NVIDIA, and I wanted to highlight really two primary verticals, one being healthcare and the next being financial. So within healthcare, there's several different use cases that we're seeing, and I'm going to kind of just go through these fairly quickly to give an example of the types of companies that are starting and evaluating and looking at applications in this space: clinical care, operational efficiency, precision medicine, drug discovery, things like that. Now, if we look at the financial space, there's a lot of different potential use cases here. Underwriting, fraud detection, risk simulations, trading, credit card companies and more efficiency in processing, customer service, personalization, and personal finance. So really, again, a lot of different use cases that we're seeing. And this goes back to really, if you think about it, it's the same, if you kind of go back in time, call it, 15 years ago when the public cloud first came out with AWS, large enterprise companies are having to decide, do I stay on-prem? Do I go to the cloud? And it's really the same thing happening over again with this, that it's a different application. So we are seeing that, enterprise companies are evaluating that because there are those choices today that the big guys that we've talked about, like an AWS, Microsoft, and Google, do offer GPU and compute as a service. Some companies, though, like a lot of the healthcare and financial, are looking for on-prem as well. There also are other, what I would call startup CSPs, cloud service providers, that are also offering GPU and compute as a service to large enterprise companies. So it kind of goes back to this. I was saying cloud, cloud versus on-prem, and really the considerations with that. There are many, but like we've seen in the past, folks that have some of the reasons like why healthcare and financial companies have maintained an on-prem environment is because of things like security and risk and control. Cost is obviously another factor. In terms of with the cloud costs. So, but the reality is we'll likely see a hybrid model like we have in the past, and we'll continue to see that as we go forward, meaning both a combination of on-prem and cloud likely. So a little bit on because some of the market forecasts, just considerable growth expected. The overall, this is a data point from the overall AI market, valued at 142 billion. With a growth rate of over 17% per year. So pretty high numbers from a growth standpoint. So if I take a look a little bit closer at that, and this is looking at the server forecast from the 650 Group market research company, and this looks at volume in units. And if we look at traditionally, right, servers have been an x86 based, but if you look at the yellow here is highlighting the AI and ML, and forecasted to grow at 47% over the next several years. 40%, excuse me. Another view of that, they looked at bandwidth required over the same period of time, and really the growth within that by market, but it's really by application. So this is blue is layer 2, orange is layer 3, gray is data center interconnect, and yellow is AI. And if you look at the growth rates expected across the board from a bandwidth standpoint, they're pretty significant, led by AI. Overall, a 50% growth in bandwidth required for these different applications. So one of the key differences and challenges a little bit with the AI networks is really the more utilization of InfiniBand. InfiniBand has been around for a long time. It's been fairly focused in the HPC sector, but we are seeing this being utilized more primarily, for the AI networks. A large majority so far are utilizing InfiniBand. I think the number is roughly about 85% probably today of the market is NVIDIA and InfiniBand. And we see on the side here, I kind of highlight, there's really two sides. There's a front end network and a back end network. The front end is really the traditional space, is traditional leaf spine, and primarily been Ethernet. And on the back end is really the new side of it is for the AI compute leaf and spine, and that can be either InfiniBand or Ethernet. But today, really, the InfiniBand excels, has better performance because of the latency and is a lossless solution. But really, both Ethernet and InfiniBand are expected to coexist in the future. Ethernet is expected to grow, driven by performance enhancements that's being worked on by a lot of the leading manufacturers across the industry. The Ultra Ethernet Consortium is one of them, the groups that is driving a lot of that. Because really the goal is to have a multi-source ecosystem. Today in InfiniBand, there really is not. So, but most end users want there to be a multi-source ecosystem available. But the mix, there is expected to be a mix across Ethernet and InfiniBand. So if I take a look at what the forecast is for AI, and just from a switch standpoint, this is also from the 650 group, and they expect to be, again, you can see the switch over to Ethernet. InfiniBand, there's going to be a lot of, has been a lot of growth. This is in volume of just switches. And if you'll see the growth in Ethernet here in the back end as well as the front end. So some of the key differences with Gen AI, really this is a summary of those. There's really some of the key challenges: the high bandwidth, the power consumption, the InfiniBand and Ethernet that I mentioned, and low latency requirements.
Where was he, and was he okay?
Okay, sorry about that. So if you look at the server speeds, they are really changing in different applications. So 10, 25 gig, 100 gig is being used for inferencing, and primarily on the model training, we're seeing 200 and 400 gig, and then they are starting and planning for 800 gig and 1.6 terabytes, believe it or not. So where are folks on the journey? This kind of just looks at the spectrum I talked a little bit about before was training and inferencing, but I think there's starting at an idea stage, and people are experimenting. We're seeing a lot of that right now. Then they move on to training, and typically there's retraining and experimentation, a loop that happens here. And at this level, we're kind of the 200, 400, and starting 800 gig. And then starting to move into inferencing. So a lot of right now, I think in the market, we're at training, but starting to move to inferencing applications. So what are some of the considerations and the impact to DC designs? So if we take a look, typically there's what's called a reference architecture. Most of the leading manufacturers and the hardware vendors have developed RAs to provide guidance to end users. And it's really is just a recommendation and guidelines for best practice. So NVIDIA and Dell and HP and some others have developed these. And again, it really is a roadmap for planning. But I think I want to highlight that this is really meant as a guideline, and it doesn't mean that it has to be or can be followed exactly to the T. NVIDIA says it has to be, but most people are maybe you're not able to do exactly what they recommend, or you're adjusting based on your particular scenario. So typically within an RA, there is 4 separate networks: a compute fabric, a storage fabric, in-band management, and out-of-band management. So in the compute, it's typically been InfiniBand or can be Ethernet. The storage is typically Ethernet, 100 or 400 gig. In band is 100 or 400 gig, and out of band is 1 gig Ethernet. So I want to just give a couple examples of some of the hardware and some of the RAs that are out there. So this is the NVIDIA the A100 that was introduced back in 2020. And this really the key points about this, in terms of the power is probably one that probably the single biggest factor is power, and the biggest thing that's driving amount of change in the data center. So this box is 6.5 kW for one node. As a reference point, if you're not familiar, the typical server cabinet today across the industry is probably anywhere from 5 to 15 kW max per cabinet. This is 6.5 K for one server box. And then this has typically 4 or up to 8 connections per box using QSFP56 for 100 or 200 gig connections. So if I look at, then they introduced the H100, which was actually a couple years ago now. It's pretty common now. This moved to 400 gig. 8 connections did move to an OSFP form factor in the box, and the power is now over 11 kW per box. So again, it's really that the power is really probably the biggest challenge, and forcing people to rethink how they're laying out the data center. That it's driving spreading out more than you typically would. And then the latest one introduced at the recent conference from NVIDIA was the B200 GPU. So that's 400 as well as 800 gig using the new Blackwell chip. And you can see here, this is up to over 14 kW per box. So again, some pretty crazy power requirements that we're seeing here. Now, just to give a couple examples of some of the reference architectures that from NVIDIA and others. So this is their base pod for the A100. It's designed up for 10 nodes and really targeted at enterprise customers. You can see showing an A100, and it really starts with 2 or 4 nodes and can work with third-party storage and can be InfiniBand or Rocky compute in this. Another example is their next step up is the SuperPod architecture for the A100. This is really for 128 and beyond nodes. But really, the concept is these pods, which is a scalable unit. And this is an example of that. This is showing 4 nodes per cabinet, per compute cabinet. And the reality is, like I said, a lot of people can't even support that in terms of the power. So this would be 25 kW, let's say, in one cabinet. So you might have to spread these out more than you traditionally would. And then one network cabinet for these as well. And then as you scale this out, all scalable units and pods are interconnected with each other. So another example of this is their H100 SuperPod. So this one is a 32 node scalable unit. Again, they're kind of showing 4 different nodes per cabinet, but again, can be just spread out more than they show here, and then 2 network cabinets. So this is an example of a full 128 node cluster. And I like this diagram just because it just shows the complexity really that is involved with these networks and the number of connections that they have. So I'm showing you at the bottom our H100 scalable units and those servers going to leaf switches, going to spine switches, and into a super spine. And all these black lines are connections in between these switches. So it really is an incredible amount of connectivity when you're interconnecting all of this hardware together. Here's another example. So outside of NVIDIA, so Intel and AMD are 2 other of the GPU providers in the market, and their Gaudi 2, this is an example of their chip, and their Megapod reference architecture. So this is a 3 cabinet pod. They currently show Supermicro servers with Arista switches in a 3 cabinet pod. And this is Ethernet and utilizing Rocky for the compute fabric. You can see 8 servers and 3 switches per pod. So in this type of a scenario, you can utilize copper DAC since there's a short distance, right, between the server to leaf connections. Here's an example of a design that we've done and might be common within the marketplace. So this is back to using, this is an NVIDIA example of the HDR application, and really utilizing a hybrid cabling design. And by that, I mean a combination of both point-to-point and structured cabling. And because the reality is it gets, some of the hardware manufacturers recommend point-to-point specifically, but it, a lot of the end users have realized that it gets very difficult to manage and add to it in day two work when you're doing all point-to-point. So having some, we're in this, I'm in the structured cabling industry, so most people understand the benefits of structured cabling. And this is even more so because there's a lot more interconnectivity. So in this example, I've got five compute cabinets, 4 nodes per cabinet. And here I'm showing point-to-point connections from each server node to the leaf switch. And then these runs are showing structured cabling between network cabinets. So these are patch panels up at the top here. And this would be another scalable unit and a group of another pod. So you're doing structured cabling between these cabinets and then patching down into the spine and leaf switches. So we expect this to see this as more of a best practice as folks are deploying larger clusters. Here's an example of another kind of unique application that we are seeing a little bit, and this is a kind of a hybrid application. We've got Ethernet and utilizing, this is showing an NVIDIA ConnectX-7 Dell server with ConnectX-7 cards, still Ethernet using Rocky, but you're needing to convert from 50 gig lanes to 100 gig lanes. And this using two different form factors, a QSFP-DD to an OSFP riding heatsink. And so something like this is one way of doing that in a gearbox assembly that can be used to convert that. Another example for Gen AI inferencing, as I talked about, this is looking at, in this example, I've got a Cisco switch, a 9K switch with 100 gig connections to Dell servers. And in this case, DACs can easily be used within that same cabinet. Very common for this type of an application. So just kind of wrapping up a little bit and highlighting just a quick summary of the Siemon solutions in the space. From an application standpoint, whether folks are doing training or whether they're inferencing, copper, fiber connectivity, primarily it's fiber. The copper is out of band for the out of band management. Inferencing can be direct attach with fiber or high-speed direct attach. And there's, from a fiber standpoint, there really is a lot of options there, but this is really just a summary. One thing that we did see that is unique about this environment as you move to NDR or 400 gig, it does utilize APC connectors, so MTP APC. So that is a little bit different for multi-mode. And so all of the options for that and different density options. From a DAC and AOC, there really is lots of options here. We've got 100, 200, 400, and we're just about to introduce a bunch more options here that will provide a lot of flexibility in both Ethernet and InfiniBand. Just on that very quickly. So for the fiber side, it doesn't matter whether you're doing InfiniBand or Ethernet, but if you're using a direct attached cable, it does matter. So it needs to be either an Ethernet based or InfiniBand. Just on that, I want to highlight the interoperability. We do a significant amount of interoperability testing on the DACs and AOCs. We have been doing that for years. We just did a recent one last month with InfiniBand and Rocky. So that just shows compatibility with all the leading manufacturers. So very important to have that that compatibility. So I'm going to leave it with that. I know we don't have too much time to see if there are any questions, Patrick, from the team here.
Gary, thank you. Thanks very much. There are a couple of questions, and we do have a few minutes, so a little bit of time for each. Talking about the power requirements, and cooling that go along with it for these networks, you mentioned when you were presenting that there's sort of a spreading out effect, right? Is that how the power requirements are dealt with, or really what's being done? Can you sort of encapsulate what's being done given those high power and cooling needs for these networks?
No, good question. So a few different things. So yes, right now we are seeing if folks are in an air-cooled environment, they're spreading things out more. So fewer servers per cabinet, which mostly means it's again more cabinets in that amount of space. So they're using fiber more and less DACs, for example, but also other things like moving to liquid to chip at the server is being done, and even immersion cooling, full cabinets immersed in liquid to be able to get full density of those cabinets. So lots of things happening in that space to maximize the density and reduce costs for folks.
Thanks, Gary. Another question touches on something that you addressed late in your presentation, but I'd ask if you could give a little detail on it again. Are there different cabling required if you're using InfiniBand versus Ethernet? It sounds like sometimes yes.
Yeah, I did. Yeah, I did touch on that right at the end. But yeah, just to reiterate that. So for fiber cabling, again, it really doesn't matter which protocol, if it's an Ethernet or InfiniBand. So that will work either way. For like a direct attach cable, whether it's an AOC or DAC, that does need to be InfiniBand or Ethernet based, and that's IEEE based, obviously, Rocky that's being used there. So it does need to be one or the other for those types of products.
Excellent, thank you. And one final question, Gary. Again, late in your presentation, you talked about sort of cabling solutions for the inference function of AI. A question came in: are there sort of different bandwidth and therefore connectivity requirements depending on the function? In other words, is inferencing sort of the most intense and most bandwidth intensive function of AI versus, say, training?
No, it's actually the opposite of that. Training is the most bandwidth intensive. So that's, call it, like I said, 100, 200, 400 gig is mostly right now.
Right.
And then inferencing is lower bandwidth. Once it's trained, it's 50, 100 gig probably in that ballpark. So that's kind of what we're seeing.
Excellent, Gary. Thank you. Well, that sums up the questions. I thank you because, Gary, I know that this is a very compelling topic and there's a lot to it. We ask you to squash your presentation into 30 minutes. So I really appreciate you doing that.
No worries.
So we are just about at time. Really appreciate Siemon for their sponsorship and Gary for this great information. You're going to be, members of our audience, you're going to be presented with a pop-up survey asking you to let us know what you thought of this session. Please do fill it out. We take a look. It lets us know what we should be delivering to you in future sessions like this. My thanks to our audience. Gary, thanks very much to you for a very compact presentation on a topic that's so meaningful in data centers. Thanks very much, everybody. Wish you all a great day.
Thanks, everybody, for attending. Appreciate it.